Some part we have discussed already, some solutions already we have discussed, like the consensus mechanism. So that is somewhere one of the biggest solution at present which is available, which solves a lot of problems. But also we'll discuss some of the other solutions. So what are the few challenges? Again, when I say few, there are other big challenges also, which at this point of time we are not discussing. Integrating on-chain and off-chain data. So remember what we discussed. Blockchain is basically a platform where people will can transact different kind of information, right? I can transfer money right now. If I create asset, I can transfer asset. Now the problem is that is a blockchain. I have to be part of that blockchain. But what happens? Blockchain need to be integrated with offline data. So whichever information is available on blockchain, that is on-chain data. But obviously, let's say I want to create a let's say this uh, weather prediction algorithm, or let's say there is something related to this share market. A lot of decentralized exchanges work on that. So your monetary movement of those kind of price of these coins, right, will depend on economic, how what is happening in the market, news, how the news is positive, negative, or neutral, what are the economics parameter, repo rate, reverse repo rate. So all these information which is off chain, that means it is not available on chain data, because these are news articles, these are economics data which is regularly weekly published by the government, different governments, right? How will I integrate that data with the blockchain? So that is one of the major concern. On chain data, remember, whichever information is available on blockchain, off chain is which is outside the blockchain, right? Our regular, let's say somebody wants to create this kind of and I think we'll discuss that example. Medical, right? Health data information is available on the blockchain platform, but maybe the insurance records or the identification records, that is in other database, right? Or the, let's say, police records, if it was an accident and insurance is covered, and that is over a blockchain, right, to have a secure channel. But some information is over blockchain. Let's say insurance records, how many times that person has claimed earlier, how many times insurance has been claimed. So all the insurance details is available on the blockchain. So that is on-chain data. But police records, if it is accident happened, right? So that FIR and all those information with the police station, and that is something which is off-chain data. Similarly, doctor's report, that is again off-chain data, which is in medical, whichever hospitals that person get into. So that registry, right? So how to integrate that? Energy consumption, that is the biggest thing, and we'll look into some statistics. It looks like the energy consumption of Bitcoin platform is sometimes equal or more than some of the small countries, right? So how to like um, go about it? Then scalability. So scalability, again, there are different parameters. So decentralization aspect, scalability means, can I increase number of users? How many people right now using? If tomorrow, let's say, uh, normal banking people are 30 crores or 50 crores in India, people are using different banks. How many people are using transacting on blockchain? Maybe thousands or 5,000 or 10,000 maximum, right? If we want to say that, okay, within 10 years or 5 years, those 30 crores or 20 crores or 10 crores of people are going to use these kind of blockchains, can we scale our infrastructure to that level, right? Then obviously on the speed, right, how quickly we are able to cover the transaction, convert those transactions, and register that into a digital ledger on blockchain. Privacy, though blockchain is created, Bitcoin, Ethereum, all those platforms which are secure, which we have the various kind of cryptography, private key, public key, but still people are able to hack into that, right? So again, whether there are certain avenues where again much more privacy security can brought in. Then interoperability, right? So how these two are different? Here we are talking about blockchain and outside data, right? Interoperability means, if I have Ethereum blockchain and Bitcoin blockchain, can they be integrated? Can they interoperate? Right? Let's say I created a digital asset using US platform or some other platform, can I sell it using Ethereum platform? Can I sell that digital asset if I'm not created that NFT using Ethereum, but I want to sell it using Ethereum platform blockchain? Can it be done? Right. So that is where when we talk about interoperability, that is the interoperability between different blockchains, right? So these are the 5 problems or 5 challenges what we are going to discuss. On-chain and off-chain data, this is what we discussed. On-chain data is which is on the blockchain, right? Whichever records, whichever information is available on the blockchain, but there will be different information, right, which is outside your blockchain: news articles, economic data, weather data, right? Like I said, that insurance detail, police records, health registry, hospitals records, all this information will be outside. So off-chain or real world data, on-chain is blockchain world data on the blockchain, right? How we integrate that? That is something known as blockchain oracles. So this is not the ERP what we talk about, Oracle and SAP. It is not that. Oracles here is basically somebody who knows. Oracle in Latin means somebody who knows it all, right? So this can be human oracle also. That is an interesting concept. But this is a kind of a person, entity, algorithm, software code, right? Which becomes the linkage between on-chain data and off-chain data, right? So this is the oracles, not the Oracle or the SAP what we have talked about. This is known as blockchain oracles. So blockchain oracles are the third-party service providers. They provide external information to smart contracts and act as a bridge for connecting outside data to inside data, right? On-chain data, right? Think about your. So we talked about this use case a lot, and this has already like people have started using it, right? See, letter of credit, right? So whenever I'm importing or exporting certain assets, certain equipment, certain chemicals, right? So if it is outside my country, I have to put a letter of credit in the name of the company from whom I am importing the equipment or the item. So in that case, what happens? Lot of banks will be associated, lot of logistics company will be associated, insurance company will be associated, exchange information need to be associated, because on the day of payment, so see the challenge, what happens, the exchange rate need to be decided, because when I say I am buying this asset for $10,000 or $20,000 or $50,000, but I have money in State Bank of India, right? So $50,000 means how much amount of rupees? So today, let's say $1 is 81 rupees or 80 rupees. After 1 month or 3 months, by the assets are getting delivered, it might be 83 rupees or 78 rupees. It might fluctuate, right? So for that to happen, how much like actual conversion will happen? You need market data. You need that exchange information that okay, what is the current exchange rate? On that basis, the payment will be made. So all this information which is outside of the blockchain, right? Blockchain only will have your information about your transaction. Okay, I need to send, so I will have a smart contract will say that if I get the documents, these are the documents: invoice copy, packing slip, um, free on board documents, FOB documents, and then customs duty document, then warranty guarantee information, all those 10 or 12 documents. Once I get the authorized or the notarized copy, then the payment will be released. So that is a smart contract data, so which is on the blockchain. But so when I say payment will be released of $10,000 to this account, so what will be the conversion rate, how it will be sent, right? So all these information need to be come from outside data, right? And that is where your oracles help. So those third party entities, the software codes, persons, uh, sensors. Sometimes you'll get a data with sensors also, right? Let's say it is a supply chain tracking. I'm tracking all those uh, kind of delivery on a supply chain blockchain, right? So the information about the geographical where the delivery, where the items are. So it will be through this Internet of Things, those sensors, which will sending you the location data. So that location data will be coming from that hardware sensors, right? so that some chips or some sensors will be in the truck or the trailer, which will be continuously sending those information to the blockchain. So that itself will become a hardware oracle, right? So that is somewhere you define, and there are different types of oracle which we'll discuss. But before that, any questions on this? So what are the activities done by blockchain oracles? Listen, basically to get those what information is required by the blockchain. Extract information, sometimes it will be huge data, right? So you have to extract information on the exchange data on today's whatever 16th 15th whatever the November date. On this date at 10 a.m. or 9 a.m. 9:30 a.m. what is the exchange rate, right? So that is the extraction. Format data, so you have to like whatever language, most of the time smart contracts is written in Solidity. Right now people have started writing in Python and Java. So but in Ethereum most of the kind of code is written on the Solidity language. So obviously you have to make sure that the data is formatted and put into that format, right? Whichever format your software smart contracts wants to get that data in. Validate data, right? You should ensure, the oracle should ensure that that is the correct information, right? Most of the times validation is done by the human oracles, right? So there will be people like me and you who will go through the data and make sure that the data is authentic. Sometimes what happens when extracting or scrapping data online, right? Because these are lines of code, right? So if you write a line, some lines of code in Python, it will go to Amazon and or it will go to some weather.com and get all the weather details, right? Sometimes it might do a mistake getting correct data, getting data of the present scenario, right? So that can be validated, right? And most of the times validation can be done by your third party, like people like human oracles, or sometimes through digital signatures. Sometimes more computations might be required, like market rates, cost of capital, right? What is the current banking rate? Let's say in your smart contract it is written that for that week, so we'll not look into the single day exchange rate because it might fluctuate due to some event that day. So we'll look for that average weekly exchange rate or average monthly exchange rate. So for that particular month, when delivery, let's say I put an order on a month of November, the delivery of the items will happen on month of February. So on month of February, whatever the average exchange rate, so payment will be made. So average exchange rate 80 rupees 50 paisa or 83 rupees 25 paisa. So that calculation or computation the oracles can do, and they'll send the data to the smart contract. Broadcasting, so again sending that okay, the payment has happened, it has been registered, so the information will be sent to, let's say delivery has happened and the smart contract release the fund. So the broadcasting of that fund release to different banks, to different stakeholders, importer, exporter, who was exported and who was imported, that information can be broadcasted through oracles also. Then output, sometimes the information can be like you can record it and put into a separate blockchain itself, right? So that is somewhere like what are the normal or the some of the work which oracles do. Mostly, so simplify it, they collect information outside data, they clean it, they put it, format it, sometimes computation is done, then that computed data is fed into the blockchain, right? So let's say I want to, so same example, right? So I, as an importer, I ordered few items outside USA, let's say MacBook, and 10 MacBooks or 30 MacBooks for my employees. And the smart contract is being made that on this particular day when the delivery will happen in my warehouse, right? The payment will be made to the Apple, whatever the retailer in USA, right? So and it goes, so the delivery details, the blockchain oracles will be collecting when the parcel reached at what location right now the MacBooks or the which whatever items I have ordered right now, in which location they are in. So it will be continuously collecting that data. At the point when it reaches my warehouse, so it will collect that information. Then it will collect other informations also, on the exchange rate. What is the exchange rate happening for that month? So once it collects all the information, compute the, let's say, average exchange rate, it will send to the smart contract. It will send that, okay, all the delivery has been made, my warehouse manager has signed the invoice, so these are the document. And once smart contract received it properly formatted, smart contract will put, like, it is basically nothing, it is a if and else, right? If I get this information, fund will be released from my bank account to the retailer's account. So that information will be sent and it will be broadcasted. So broadcasting also will be done by the oracles, right? Simply these are the few activities by the blockchain oracles. Any questions on this? So human oracles, like I said, people sometimes, which that artificial intelligence or it cannot be just verified by code of some lines of code, right? You need to have persons who will go through that data and verify it before feeding that into it. So people like you and me can play that role, right? Software oracles, obviously lines of code which are extracting or formatting that data. Outbound oracles which broadcast messages. Inbound oracles which take information and bring it to blockchain. Decentralized oracles. So these are all independent oracles, right? Sometimes centralized oracle, all the information coming to single point and getting broadcasted from that single point. Decentralized means all the information are going to different nodes, different kind of oracles, right? So this is again a big challenge. Remember what we discussed. One of the biggest impact of blockchain is to make it decentralized, right? No single authority, single node will have all the power, right? But sometimes what is required in case of this kind of system to speed, to make the access or make the blockchain transactions much more simpler or much more faster, right? They might use a centralized oracle. All the information will coming to single point of contact will be broadcasted from a single point of contact, right? Otherwise, what will happen? All the information need to be verified in all the nodes, right? And that is somewhere the challenge remains still. Then hardware oracles, these are the sensors, like I said. If you want to take weather information, if you want to take the supply chain related information, so some trackers of some sensors will be in that trailer or the truck, right? And continuously they'll be sending the data at which location, all the GPS data, all the location data, information, temperature, weather, all the information will be coming through those sensors. Then contact specific oracles, that is again specific to that smart contract, right? For a particular smart contract, I can write some lines of code, look into, let's say, some weather data or some exchange data or some specific data, sensitive data for a period of time. Let's say for this month, November month to January month, right? So that will be, that oracle will be live or active for that 2 or 3 months only. Once that 2 or 3 months gone, it will expire. But think about a hardware oracle. So once you put that sensor itself is oracle. It will keep sending unless you switch it on or switch it off, right? So it will keep working for a infinite. Obviously it might get damaged, but unless it gets damaged or malfunctions, it will keep working, right? So these are different type of oracles. Some of the key things you have to remember: human oracles, yes, persons can become oracles; software oracles, hardware oracles, right? So these are the some basic things you need to remember. Any questions on this? So the oracle problem of blockchain, first is blockchain alone cannot access outside data. So that is solved by the use of this kind of software lines of code or persons which are known as oracles, right? Because blockchain cannot have access to outside data. So blockchain oracles work as bridges between outside data and blockchain data, right? Next, the question which you was discussing, decentralized oracle and centralized oracle. Sometimes to make it faster, right? People use, rather than decentralized, people use a centralized oracle, right? A single point of node, a single node which is discussing, which is deciding many aspects of blockchain. But the challenge again remains, if it is a single node or a single software line of code or a single server, which all the information is going in and going out, right? It might get hacked, right? And that is somewhere your centralization aspect has gone away, and we are putting into decentralization concepts, right? So again, that is something which we'll discuss during scalability aspects also. Lot of discussions are happening how to maintain the decentralization aspect of blockchain but make it faster, right? So let me give you a same example, right? So what we are basically discussing about, let's say we have different nodes, right? So that is the aspect of decentralization. All the nodes are acting independently. So if some information comes regarding exchange rate, weather data, or the geographical location data, all the nodes need to independently verify that data, right? Every second, every minute, some information is coming, right? So it need to. So obviously, if it is a supply chain data, it need not be every second. Every 6 hours or 3 hours, I can put it. But think about an exchange. Think about those decentralized exchanges where you can buy Bitcoin or buy and sell Ethereum, hundreds of cryptocurrencies. So in milliseconds, it should get the information that okay, on which exchange, what is the current exchange rate of Bitcoin, current exchange rate of Ethereum, right? So that information has to come in milliseconds. So if I'm putting thousands of nodes, each node need to verify that data independently because that is the meaning of decentralization. All the information will be in all the nodes and they can verify it independently, and so that is why it becomes slower. It takes a lot of time, it takes a lot of effort. But again, if I say that okay, no, we'll keep it centralized, we'll keep it only one or two places, all the information will come there and all the information will be processed there, somebody can easily hack into that. And just think about a hacker, somebody who is trying to maliciously tamper with the data. Hacking into only one server or one laptop or one kind of system is easy rather than hacking into simultaneously 100 servers. And that is where you remember 51% attack. So if you want to hack into Bitcoin or Ethereum, at that point of time, the number of nodes are active. At least you should have the able to hack more than 51%, right? Majority of nodes, which becomes little difficult as and when the number of nodes increase. But if I'm putting a centralized node only single point of uh, place, single software line of code, single server or a single system, hacking becomes easy. So that again becomes a problem of a security. So that is somewhere you have to keep the balance. How many nodes you have to keep? Obviously, centralization is not the solution, but centralization makes the things faster, right? So, any questions before we proceed further?
Sir,
Yeah.
I just want to ask if
Yeah.
there are two or three centralized servers to process the data, so will not be it the hackers will get problem while attacking them because it will have
So once it
securities
becomes two or
also.
three, it will not be centralized, right? It becomes decentralized. So more than one means it is decentralized. Your information is not in a single server or a single system. So decentralized meaning, so nobody has specified that okay, how many number is minimum required to have a decentralized base. The more the better. Same information, think about this. If right now there are only 20-25 students, if I want to hack into all your systems and we are running the same program, I need 12. I need the power to hack into 12 systems. If 1,000 students are right now in this place, thousands students are running or validating certain kind of information. If I want to hack into that system, I need to at least have 501. I need to have that power to hack into 501 systems. So to answer your question, there is no definition of minimum this number of systems are required to make it decentralized. More than one means it is decentralized. But as big as many of nodes are there, it is better. So was that your question? You wanted to know about centralized and decentralized?
Yes, sir. Yes, sir.
So so again, decentralized has its own challenge, which we'll discuss now. Energy consumption is one biggest challenge right now with blockchain. So how much terawatt hours? China, I think this was in 2019, and this Bitcoin figure is 2021. So on an average, Bitcoin platform is kind of consuming around 143 terawatt hours, and compared to other countries, if in Norway, Bangladesh, it is almost double of Bangladesh total energy consumption. I think India will come. I don't think India is there, but India, I think around 1400 terawatt hours. So 10% of India's total energy consumption. So obviously, it is a big challenge in terms of how much energy consumption happened. If I compare all the Visa system, most of the our credit card, debit card, or the payment transactions happening over Visa or Mastercard, right? Estimated kilowatt hour per transaction is 0.01 or less than that, right? It is again a very roughly estimated figure. Bitcoin is taking for this say one transaction, it is taking on an average 200 kilowatt hour. Ethereum is around 37 kilowatt hour, but again Ethereum will reduce, so they're moving into different mechanisms. So it will come back to I think 3 or around 2 point something kilowatt hour. Still, it is more than the normal kind of power usage which happens in Visa or Mastercard. So now what is the solution, right? So if you remember in between Elon Musk started taking payment of Teslas on Bitcoin, in between he stopped, there was this tweet saying that because Bitcoin is energy consuming, so we will not be accepting uh, Bitcoins. In between, like I think last year only they started taking Bitcoin payment per Tesla delivery. Then they said because it is taking a lot of money, it is taking a lot of energy consumption, so we'll not will stop taking Bitcoin for Tesla delivery. Now, I think so. The condition they put is if you move into the renewable energy rather than coal based or power based, you get into the solar, wind, right? So we'll start considering taking again the Bitcoin, and that was the I think most of the governments also look into that fact because blockchain platforms take a lot of energy, right? So either you make a energy efficient systems or move into renewable energy. So that is how somebody did a research on how much blockchain is consuming. So interestingly, what happens? Most of the blockchain right now, I think then again moved into USA and Europe. Last year before China, and this year only China started breaking or demolishing all those blockchain gigs. But before that, most of the mining used to happen in this C1 province of China. 48% is total mining share of Bitcoin mining, around close to 50% used to happen in this region. Out of that, if you see, renewable was 43.2%, right? So the meaning of this is already they have moved into, because see, it is not that they want to save environment, but in some area, some kind of locations, they already have this kind of nuclear plants, they already have this kind of wind power, they already have this solar power, right? So those are the countries which will benefit because the energy, if they you have already renewable energy infrastructure in place, you will be able to, like I think Ecuador is using those volcano, the power from the volcano, the uh, air pressure from the volcano or the thermal power from the volcano areas, right, to create Bitcoin rigs. So that is somewhere your usage of your renewable resources of a country will be useful to run this kind of platform. But again, having said that, the quantity of energy you are using is very high. It is close to a country's annual energy consumption. There are other ways to move away from your different blockchain platform. Cardano, Ethereum are the good solutions. Like I said, those are the major competitors for Bitcoin platform, which are less energy consuming. There is something which is very interesting, Hedera hash graph, right? So they use an algorithm called hash graph, which is kind of very like it is almost less than the usage by Visa or Mastercard, right? And again, much more secure than the Visa or Mastercard platforms, right? And this I think has a huge potential. Not necessarily this algorithm, but the usage of this algorithm, right? So the point is you have to move from, so because most of the consensus mechanism when Bitcoin started is proof of work. So remember what we discussed in initial classes. You are creating certain random number which need to be less than certain random number, right? So you are basically finding that nonce, right? Which will create a random number less than certain random digits. Then only you'll say that okay, I have solved the algorithm, right? It doesn't have any actual value to society, right? So when we talk about that mathematical problem, it really doesn't have any societal value, right? You are not solving a mathematical problem as such, you are solving a puzzle for that moment of time, and that puzzle keeps changing, right? So rather than making it computationally problematic, right, computationally complex, right, so we moved into those proof of stake. So I have, let's say, 100 ethereum or 1000 ethereum. I'll invest in that exchange, in that platform, and I will have some ownership or stake validating all those transactions, right? And that is where the difference of proof of work and proof of stake. Rather than solving a puzzle, now what you say, whatever money I have, some portion of it I will invest there, and so that will be like back my collateral, right? So I should not do any mistakes, I should not do any malicious activities, and I'll get those transaction fees. Some amount of that I'll get because I'm validating those transactions. So rather than proof of work, then proof of stake, then we discussed about different aspects, proof of authority, proof of capacity, right? Then Byzantine fault tolerance, right? So though there are many kind of aspects to it, many different algorithms rather than proof of. So what we're discussing for Bitcoin, the problem is proof of work algorithm, but unfortunately they cannot move away from it. So they are still continuing with that. Ethereum started with proof of work. Now they have moved into proof of stake, so which is why they are using less energy than Bitcoin. But still, it is much more than Visa or Mastercard. So that's why other algorithms like Cardano, Hedera will be successful in future, right? So other algorithm like proof of authority, proof of capacity. So these actually work on something concept called DAG. Uh, so this is basically where randomly some nodes will be selected and they will be given the authority for a certain point of time. Then again, the next step, some random other nodes will be selected. So that is how and the like kind of staking or the validation will happen. So these are the basic two methods where we are approaching the energy consumption issue. Any questions on this before we proceed? So we have discussed integration of on-chain and off-chain data. We have discussed the challenge of energy consumption. Third is the scalability trilemma. Why it is dilemma? The dilemma is there are two things you have to balance, right? I have a dilemma of whether work here or whether work somewhere else, right? So that is the dilemma. Trilemma is if there are three situations, 3 points I have to balance, right? So let us look into those trilemma. One is decentralization. Like I said, the more number of nodes I have, more decentralized my network is. But the more nodes I have, the validation, verification of any information will take time, right? So that is a decentralization aspect. Security, obviously, more nodes I have, more secure my network is. The example of what I was giving. Right now it is 27 students. If I run a blockchain using all of you, if an outside hacker is there, he just need 12 or 13 laptops to hack, 13 systems to hack to get into my blockchain. But same thing if I run with 350 students. So at least he has to get into 175 laptops, 176 laptops, looking into 51%. So that is somewhere the security also increases when number of nodes increase. But what happens, the problem with us, and when the number of nodes increase, verification takes time, scalability becomes a problem. So what do you define by scalability? Your transactional throughput and future growth. Future growth means number of people using that system, number of people using that blockchain platform, right? So that is the future growth, number of users. Transactional throughput means how much transactions per second you are able to complete, right? So that is TPS, transactions per second. So if you look into this figure, Visa per second are able to process around 24,000 transactions per second. Look into Bitcoin figure, only 7, which is very low. So per second, only if you are able to complete or verify 7 transactions, it is the think into this way. If 10,000 people, 10,000 transactions are there, and you are at 9,000 transactions, by the time your number comes, your transaction is verified in blockchain, already 2 days would have gone, or 1.5 days would have gone. Will you wait that much of time to verify transaction, which is very poor, right? Ethereum actually used to be 20. Right now they have increased up to, I think, 200 or 300 transactions, or much more than that. So they are improving a lot. But the main idea is, if you are looking into a full-fledged like a Visa or a Mastercard system where every transaction will be faster, it we have to get into this problem. We'll get into this problem because as and when we start playing with the scalability, right, decentralization aspect and security aspect will be a problem. We have to compromise here, right? Because Visa and Mastercard are centralized servers, right? So there will be single servers, replication of servers, backups are there, but where the information is getting processed. But here, what happens? The same information need to be processed, verified, validated across 10,000 nodes, 50,000 nodes, right? And that is where transaction per second speed is very low. So everybody understand the problem what we are having with the current scalability issue with blockchain, or any problem, any issue. Okay. So now what are the solutions? So there are two types of major solutions divided: layer one solution, layer two solution. Layer one solution means whichever is in the current blockchain platform, right? So if I'm looking at Ethereum, or if I'm looking into Bitcoin, so without getting a second blockchain, without creating a separate blockchain, what I'm trying to solve in the same blockchain, same layer, right? So that is layer one. If I'm creating a separate solution, creating a new blockchain or adding certain features in a separate blockchain, right? So that is something known as layer two. That is over the current or the existing blockchain if I'm creating a solution over it. But if I'm creating within that blockchain, within Ethereum or Bitcoin, so that is layer one solution. So let us discuss layer one solutions. Obviously, same thing what we discussed during energy consumption, right? Consensus protocol improvement. Rather than everybody looking into creating that random number, generating random number, looking for that number, which will create a hash less than that specific 17 digit, or with 4 zeros or 17 zeros in the beginning. If it is moves into different consensus mechanism, because that will be faster, right? Rather than somebody solving. So to solve those cryptographic puzzle, you need a lot of power, right? It will take a lot of power. You need a lot of energy. You need a lot of time also. To solve that problem, it might take 5 to 10 minutes. Average block creation time is 10 minutes in Bitcoin. Sometimes it might be 2 minutes. Sometimes it might be, if it is a hard puzzle, 17 to 18 minutes. But in proof of stake, based upon the number of amount of money I have invested, I will have a authority to validate, right? And that is where it will be little faster, safer, right? That is where the consensus protocol improvement. So in the Ethereum itself, in the Bitcoin itself, I'm changing the consensus. So Ethereum changed their consensus mechanism from proof of work to proof of stake. Then this is the threading concept, which is basically kind of a already we have used in distributed ledger system. What happens? Rather than all the nodes doing all the activities, so what happens in a Bitcoin or Ethereum? If there are 10,000 miners or 10,000 validators, information will be going to all the validators, all the miners. They will be verifying that. Then if they agree, 51% of them agree, block will get created, right? So that is how it works. Threading is not all the activities, not all the transaction verification has to be done by all the nodes, right? If automatically, let's say, right now 3,000 transactions are pending, 1,000 nodes are there. Rather than each of those nodes verifying 3,000 transactions to at single point of time, it can be divided. So shards can be created. Some nodes will be given certain specific tasks, certain verification of certain transactions. So look into this way. If let's say in Bitcoin 3,000 transactions are being processed and there are 1,000 miners, each of the miner has to verify those 3,000 transactions. So that is how it is so much complex and so much secure. So rather than doing that, if randomly you create different nodes and some transactions will be assigned to those nodes. So that is the creation of shreds. Shreds means the segments or the number of pieces, fragments, right? So shredding is two types: transaction shredding, which I just discussed, or state shredding. Transaction shredding means assigning different transactions to different threads, right? So that is where parallel processing happens. 3,000 transactions are there. For each node, I'll give three transactions randomly to verify, right? Rather than that single node verifying 3,000 transactions, now each node only have to verify three transactions. So obviously it will be much more faster than the original algorithm. Then state shredding means the collection or the, so remember, each Bitcoin, Ethereum, whichever blockchain we are talking about, all the information need to be stored in all the nodes. So whatever your original blockchain, everything will be downloaded in your laptop, in your system. So that is the meaning of decentralization. There is no single location where all the information is there. All the information at any point of time, at any given point of time, is at all the locations, right? So that makes your, obviously, capacity, your hardware capacity need to be there. Also, going through all the data becomes difficult, going through all the past transactions. So that is where, if you divide those information rather than keeping all the information in all the nodes, segregate randomly and keep changing that. The problem is, if you identify that, okay, node 1 will have this many transaction information, node 2 will have this many transactions. If you are able to create algorithm which will be able to change those information over different nodes, then that also is a good secure mechanism, right? So that is known as state shredding, right? So data state to be stored in different pieces on different nodes. Single node is only responsible for saving a portion of the ledger. So otherwise, what will happen? All the blockchain ledger, Bitcoin ledger, Ethereum ledger need to be in my laptop. Rather than that, I'll have some information, you will have some information, all those 27 students will have different information. Then obviously it should deliver atomic composability, right? So obviously at the end, those 3,000 transactions, right? After verification, it will be able to get together and create a block, right? So that is known as atomic composability, right? When I'm dividing something, when I again join them, they should give me the same information, same state, right? So that should not be any challenges that, okay, some node make a transaction that, okay, uh, let's say Pius send 2 rupees to some person that I verified, and I have only 5 rupees in my account. Then in another node, I've said that, okay, Pius have already sent 6 rupees, which is not possible, right? Which should not be possible. So that is something we need to look into, right? Otherwise, what will happen? Different nodes, that I made 5 transactions. I have 10 rupees in my account. I made 3 rupees each, which should not be possible, right? So that is where atomic composability comes in place. So whenever you are looking those transactions, those 6 transactions in processed in 6 or 5 different nodes, the addition, the culmination or the integration of those transactions should happen in such a way that the original state is not getting hampered. If I have 10 rupees in my account, it should make sure that I can transact only up to 10 rupees, not more than that, right? So that is where the atomic compatibility place has uh, puts in place. Otherwise, what will happen? I'll try to kind of bend, or I try to play with the system and create false transactions. Any questions on this? Then layer 2 solutions. So this is somewhere which you look into. Rather than putting all transactions, all information in the Ethereum or Bitcoin blockchain, can you take some information outside and put into different blockchain, right? Whichever important information, keep that into blockchain. Other information, create a parallel blockchain, right? So this is where somewhere you discuss about layer 2. I'm creating a different layer. In the first one, what we discussed, we are looking at changing the algorithm, changing how algorithm works, changing how verification works, right? So that is the layer one solution. We are not creating a separate blockchain. Here, what happens? You are creating a separate blockchain or a separate state. So it is a nested blockchain where you will say that okay, my parent blockchain is Ethereum or Bitcoin. Parallelly, I'll create a blockchain, right? And parent blockchain will delegate certain transactions to the child blockchain, right? So actually, Ethereum is putting into this kind of Omega Plasma. Ethereum project is called Ethereum Plasma. So they are creating all the important information, important work will be in the parent Ethereum blockchain. Parallelly, all the transaction information will be validated, verified in the Ethereum Plasma blockchain, right? So basically, you are creating a parallel blockchain so that your speed of transaction will improve. State channel again, kind of a new concept. So what basically do? So it is not a blockchain is not getting created. So see the difference in nested blockchain. Actually, you are creating a blockchain. Parent blockchain is there. Under that, there is a another blockchain. So it is a nested. So one blockchain is there. Under that, there is another blockchain. State channel is think about in this way. There is a company here in India. There is a company here in USA. So what used to happen if I am importing regularly, yearly basis or every quarter, every month, I am sending certain items, making that payment, right? Or let's say inside kind of India also, right? Not necessarily outside India. So there are vendors, there are suppliers, right? And there are the company which is buying item and making the payment. Let's say ITC or Maruti India, right? They are buying different components every now and then from different vendors and payment also being made regularly. So if all the payment, all the transactions are happening over blockchain, so what will happen for each transaction? Today I made a payment, today I delivered item, payment was made. Tomorrow some items were delivered, payment was made. All the information every day has to get into blockchain. So it makes the blockchain very clumsy, unnecessary information getting into that blockchain. So rather than doing that, so if I know that there is a regular payment to be made, so these kind of systems, I can create a separate channel. So what do you mean I'm not creating a separate blockchain? What will happen? I'll create an algorithm or I'll create a line of code which will make sure that let's say in a month or in a quarter, some vendor is supplying 10 delivery, 10 shipments to Maruti. And for each shipment, Maruti is paying certain money to that vendor, right? So all this information will be outside blockchain because let's or every day, every week, whatever delivery is happening and Maruti is paying. All this information will be outside blockchain. But on each quarter or as decided by both the company, right? Each quarter basis, the transaction now will be validated. Okay. So on this quarter end, this much delivery happened. Let's say 10,000 tires or 20,000 tires or 1 lakh tires were delivered from MRF to Maruti and this much money was transacted. So that record, the final record will get into the blockchain, not each weekly delivery or each daily delivery, right? Because that is irrelevant. I want to keep only the quarter wise detail. I want to keep half yearly detail or yearly detail, not each day detail. Each day detail, delivery detail, or each weekly delivery detail can be done parallelly in a state channel. So that is not a separate blockchain. That is just a algorithm. You put a line of algorithm, put line of code, which will have this kind of arrangement. That okay, on this day deliveries will happen, on this day this payment will happen. But the final tally from let's say January 1st to March 31st. Total 10 deliveries has happened, 50,000 tires transported or delivered in Maruti plant, and the payment was made this. This information finally will get into blockchain. So rather than making 20, 28 transactions or 15 transactions over 3 months, you are making only single transaction. You are recording only one transaction on the blockchain. So that is how the state channel works. Any questions on this? Nested blockchain or state channels?
So here it
Yeah.
is written that OMG Plasma project. So
Yeah.
what was it all about? Like what did it contain?
What?
So
Can
that
you please?
OMG Plasma project.
So like I said, Ethereum is right now creating a separate blockchain out of the parent blockchain. So Ethereum has their ETH blockchain, Ethereum blockchain. So they are creating a separate nested blockchain out of it. So what means some information, some transactions will be routed to that child blockchain. So that project is known as Plasma project, Ethereum Plasma project. So
Yes,
you,
sir, understood.
yeah. So that is basically a child. So basically, parent is the Ethereum blockchain. Then there will be separate blockchain. So it will be linked with your parent blockchain, and some transactions or most of the transactions will happen in the Plasma kind of blockchain, and the like important transactions, important information only will be recorded in Ethereum. Let's say NFT is being created, right? Not all the NFTs kind of whichever is being transacted, right? Every day, every week, NFTs ownership keeps changing, right? If I start recording everything on the Ethereum blockchain will be overloaded, right? Right now, a lot of NFTs are being made, created, and sold over Ethereum blockchain. Recording the ownership, if I'm using the Ethereum blockchain, so lot of data will be created and lot of unnecessary information will be recorded over Ethereum. So what right now they'll do? So they have created this Plasma blockchain. So every day, every week, whatever NFT transaction selling and buying is happening, so that will be recorded over Plasma. Over a year, over a kind of a let's say 6 months or 1 year, final ownership rests on this person, right? For that year, so that will be recorded on Ethereum, right? So that is how it will work. Same situation like state channel, but in state channel you are not creating a separate blockchain. So the part of transactions are not happening over a blockchain. So now the question is, then how will you secure it? So state channel only will work in a inter-organizational activities where vendor suppliers are there and they are transacting over a ERP system. If let's say I am trying to sell you NFT and I create an offline channel of it, then it will not be secured, right? So you have certain digital assets, and I say that will not record the transaction over blockchain. So it will not be secured, right? So state channel only will be used in case of inter company, let's say supplier vendor. So they can transact over ERP system, which is to extent secure, right? And that recordings, final record can be put into a blockchain, right? Ethereum or whichever. But if I'm like people like you and me want to transact or sell or buy NFTs, it still need to go through a blockchain because we do not have a separate system. Companies have ERP systems, right? So they can still transact, make payment over that. Final record of payment can be moved into blockchain. But if you and me want to transact, it still need to happen over a blockchain. It need to be secure. So that part will be through these nested blockchains. So transactions will happen over Plasma blockchain. Over the year, the main transaction or a single transaction, combined transaction will get into Ethereum. So that the load of maintaining all the information on Ethereum blockchain will reduce. Clear that any doubt on difference between these two? In nested blockchain, actually one separate blockchain is being created from the parent. In state channel, you are not creating a separate blockchain. Blockchain will be there. Some transactions will happen offline or through another system, and the final kind of event will get recorded. The like culmination event, let's say in the quarter, this much delivery happened, this much shipment happened, and this much amount of money was transferred. That information will get into blockchain. That is how it works. Then there is something concept called side chain, right? So side chain little different from the you what we discussed on nested blockchain. Nested blockchain, parent blockchain is there. All the protocols, all the algorithm will be moved into your child blockchain also, right? So both of them logically or algorithmically speaking, both of them are same. Only thing is that some load is being diverted to the child node. But here what happens, main blockchain and side blockchain, right? Main blockchain and side chain might have different attributes, different algorithms altogether, right? How this works, what is the block size, what is the block duration, of creation of block, and side chain will have like Bitcoin Cash, Bitcoin original Bitcoin and Bitcoin Cash. the Bitcoin Cash itself is a side chain, right? So what happens? The algorithm, the way it works. So difference between nested blockchain and side chain is nested blockchain. The algorithm, the attributes of the parent will remain same in the child and the child blockchain. But in case of a side chain, it can be parallelly working, but it can be different attribute, right? So to give an example, let's say this is the proof of work mechanism Bitcoin. I can create a side chain with different consensus algorithm, proof of authority or proof of capacity, to take some load out of it, right? State channel, exchange of data, move to a second layer on top of blockchain. So this is here, if you see, this is a layer. This is a not a blockchain altogether. This is a layer of information. This is actually when you talk about side chain or a nested blockchain, you are creating a separate blockchain. In nested blockchain, the attributes will remain same. In side chain, the attributes will be different. The consensus algorithm itself might be different, right? And any questions on this three types of layer 2 solutions: nested blockchain, in your state channels, and side chains? Okay, so we'll stop. Okay, well, just complete this and we'll get into privacy and interoperability. We'll discuss in next class. Okay, so there are 2 or 3 slides more. So last two we'll discuss in next class. Let me just complete another two solutions. uh, Other way to like make number of transactions more. So right now the each block is limited to 1 megabyte. The size of the block, the information it can kept in a single block of Bitcoin, right? So that was 1 megabyte. So some people or some developers started questioning it, why that small, right? So they started writing Bitcoin Cash, right? That has a blockchain, that each block have a can keep information of 8 megabyte. So that means why it is important. Many more transactions can be integrated into a single block. If it is 1 megabyte, maybe 7 or 10 transactions can be kept around. I think each transaction is around 300 kilobytes around. Again, average, some might be less, some might be more. But if I am able to increase the size of the block at least 8 times of that original, how much information I can keep, or the number of amount of information I keep in a block can be increased. So that means the number of transactions put into a register in a block can be increased, right? So that is one concept: increase the size of the block so that number of transactions recorded in a block can be increased. Other interesting aspect of looking into it is segregated witness, right? So that is known as SegWit. Remember our first 2 or 3 sessions, right? What we discussed it, what kind of information get into the block, and what and all, at the end what happens, all this information get cryptographically hashed and put into some number, alphabetical numbers, right? So what happens, each time some transactions are happening, right? Signature data also get into this, all the information, and get hashed together, right? So other way of looking into this, keep the signature data out of this block information, right? So all the transaction information, right, will be in one block. All your signature information will be in separate block. So this is the meaning of segregated witness. So witness means somebody who is looking into your information, right? Somebody who have authority. I have private key or public key. I have the authority. So I have the witness capability of that, right? I can witness my transaction. So that authority, that signatures, all those signature information, which used to be part of my blockchain data, right? So this, all this information used to get cryptographically hashed and moved forward, right? Now the system is in the segregated witness. My signatures are not part of the blockchain, right? So what happens? The amount of information getting hashed, the amount of information putting into that system, right? Information takes certain amount of size, right? So that will get reduced, and it will be little easier to hash it, right? Because it obviously time taken to have say information, right? Computationally, right? It will be little bit less when I'm using segregated witness, because this amount of information I'm taking it out from the block. So this is where your segregated witness was. The block size limit on a blockchain is increased by removing the signature data from the Bitcoin transaction. So let's say each block is around 300 kilobyte. If I remove the signature data, so each block, not each block, each transaction size, each transaction, let's say around 300 kilobyte or 200 kilobyte. If I take signature data is around 50 kilobyte. So if I remove that 50 kilobyte, right, now what happens? 150 kilobyte is there, right? So that will reduce the information processed in a single transaction, right? So the number of transactions in a block can be increased. Look into this way. If in your wallet, if I say that how many credit card you can keep, right? And for each anytime you are using make payment, you need to have a credit card, right? So in your wallet, what will happen? Maximum 20 credit card or 30 credit card you can put. You can push all the credit card and you will maximum will put 20 or 30 credit card. And that used to happen. Now what will say, you do not need those credit card. You need not have to have that physical card copied in your wallet. You just have that digitally secure number and you can make transactions. So you can put into your Amazon, you can store credit card information into your Amazon. You remember the CVV data, you can make a transaction. You need not have to have the physical card. So now what happens? I need not have to, so in my wallet, I need not have to put those cards. So there is space in my wallet. I can keep other information, let's say physical money or whatever other things, my driving license and all those things, easily I can keep in my wallet. So same situation here. So rather than keeping all the information, signature information within the block, which was taking space, take out that signature data, signature information. So in my wallet, if I say rather than keeping 5 credit cards, physical credit cards or debit cards, if I take out the requirement of keeping the physical credit cards, right? So I'll have some space in my wallet. Obviously, I'm not going to use that, but it will have some space, right? I can use that to keep cash. I can use it to keep my ID cards or some other papers, important papers. So that will help in making, so that will remove some space out or add some space in my wallet, right? So same situation here. Rather than keeping the signature data along with your blocks, along with your transaction, take that out, right? So that you'll have some space on the block. So that is how the segregated witness works. Any questions on this? Okay, so we'll stop here. The last two challenges, privacy and interoperability, we'll discuss in next class. Remember, from your next class, next two classes, there will be Viva voices for 12 marks. Yes, Abhijit. And it will happen in your group.
Joined late. Sir, I joined late, so I missed my attendance.
Yeah, roll number?
Sir, 229.
29. Okay. Anyone else?
Sir, Ashwin Nayak, sir. 291.
291. Okay.
083.
083.
284.
083 284. Okay. Anyone else? Okay.